Hi, Chris Kuzmal here. We were forking a linked list in order to create a binary tree, and so far we have transformed the file that used to be element.java partly into, well, we've changed it into node.java and done and partially modified it. Now we need to create the corresponding method to get next, which will be uh, to get the left child, which of course means that we just return left child. And that has to return something of type node. And we need a similar getter for right child. So we return the right child field. And we need to transform the get prev to be get prev to get parent. And I guess we need to do a non-code video that describes what a binary tree is, so you can kind of have the same context as we had when we were doing linked lists. So we'll do that and put that before these, so you're not as potentially confused by what's he doing? Why is he doing this? Other than, well, there we have done, I think, everything. Our testing is going to need to expose whether or not we've made any mistakes. But fundamentally, a node has a parent, a left child, and a right child, each of which are nodes and a key. And then there's methods that allow us to access those or set those. And that's all that we have so far as a node in a binary tree. Now we want to transform our linked list into a binary tree, and we'll just call it I guess we'll call it a binary tree. So we're going to rename it binary tree. Oh my gosh, why isn't it? Okay, so we have a binary tree, and it's going to have a node that is we don't call it the head, we call it the root. So it's analogous. Okay, and we don't have we actually will be wanting to be able to search the binary tree. So this method is going to need to exist, but it's going to return a node, I suppose. And it'll search on a key. And the details of the implementation, well, we can see what happens if we just transform everything that's an element into a node. And of course, get next isn't going to work. We'll try get left child. Let me tell you, that's not going to work either. So this is going to be a little bit buggy, to say the least. There's going to be a delete method as well, and it's going to take a node. And we are going to replace all the get prevs with get parent. And again, this is going to just make this not work, but that's okay. Our mission is going to be, so what's get next? Get next is, again, next is getting replaced with left child, which ignores the right child, which means that there's going to be troubles. Set left child, I guess, assuming that exists. Apparently it does. So, this might work, but this actually might fundamentally implement a linked list within a binary tree, and there'll be all these right children that get ignored. So that's fine with me. And so here we're gonna do the root equals a dot get left child. Yeah, we're just going through and we're changing, we're replacing everywhere we see get next, we're replacing that with get left child. So left child is replacing the role of next. And we'll see how much of that we can get done before we run out of time here. We have about 26 seconds. And get prev is going to be replaced with get parent. And we're just doing it blindly, okay? And we'll modify the insert method as well. And maybe it'll pass pass as a linked list. That'll be kind of cool if it works.